Welcome everyone to breaking news, or maybe I should better rename it Kernel Panic. This week's Linux zero-click remote BleedingTooth, BadVibes, BadChoice and BadKarma remote code execution through Bluetooth. Let's take a closer look. So that is just disclosed the previous days. Some CVEs also, CVEs 2020, because coordinated disclosure between Intel and Google and so on takes a while. So that is what this means, is zero click. So in summary, too long, didn't watch, very dangerous if you have Bluetooth enabled. Recurring theme, maybe don't enable remote wireless protocols that are written in C, and certainly also affecting Android. Vulnerability in the Linux Bluetooth subsystem, and with that also another data point in our recurring series C. We got this not glorified assembler macro preprocessor front end. And why we probably want to have more memory separating than monolithic Linux kernel and so forth. Unauthenticated remote attacker, so it does not even need to be paired, so it doesn't need to be a Bluetooth earbuds, but anyone on the street. Short distance execute arbitrary code with kernel privileges on vulnerable devices. They noticed this was, by the way, Andy Nguyen, plus minus pronunciation. And it is a series. Why is it BadVibes, BadChoice, BadKarma? Because that is a stack of heap stack and more heap-based type confusion. This is similar to many other vulnerabilities. If there are vulnerabilities in Chrome, Safari and stuff, usually these days they are multi-staged, often as much as chaining 8 or so, plus minus, or 5, 10, 12, or PS4, PS5. And because often, like with BadVibes, heap-based buffer overflow, that is not enough to execute remote code. So often it takes chaining one vulnerability with another. So they noticed fast extensively, but the subsystem, Bluetooth subsystem, were less well covered. Also, 2020 Bluetooth subsystem not very much fast. Also, a language so insecure that you need fuzzing. Fuzzing, if you're new to this stuff, fuzzing means not like testing of regular testing, this of pairing here like a keyboard, but injecting their random data, more or less random data, for hours and days, and see if it eventually uncovers a bug or crashes, and so on. So that's fuzzing. And also 2020, so this stuff is not yet as much fast, because you even need to fuzz this stuff because C, and could take full control over devices, question mark. And vulnerabilities, so BadVibes, C-based buffer overflow, and introduced also a recurring theme here, new vulnerabilities still getting introduced, similar to our own channel here, where we uncovered the 500 to 2000% BetterFS regression, recurring theme of, in my opinion, too many changes, too much refactoring, too much API changes just for the sake of changes, and also don't write the stuff in C. ACI event packet parsers, crafted and sent by Bluetooth chips, and usually cannot be controlled by attackers unless you have control over Bluetooth firmware as well, but obviously as an attacker you have. They go here into detail with the code, how method called process advertised, I guess, report. Later, the method does not check the EV length to see if this is smaller or equal to ACI max advertising length equals 31. They also note that this was not enough always, of course, it's enough for some crashes, oopses and stuff, kernel panic, but not necessarily remote code execution. So as I said, usually chaining more stuff together. There come BadChoice, not BadVibes, not powerful enough to turn into an arbitrary read-write primitives, and So yeah, chaining more stuff together, In total, 3 bugs with BadKarma. Also here 2020, 2021 or 2019. Security vulnerability is only a real security vulnerability with a nice advertising name. Often InfoSec vulnerability names, correct me if I'm wrong, but nowadays much better and certainly more funny than product names. Discovered, so it's not 1, not 2, but 3 vulnerabilities. Also, yeah, how amazing is to see in this? Why do I make this live stream? I make this live stream to hope to contribute to improving the state of computer science, operating systems, and why after 20 years in this industry, I want to be more vocal that we should not do this stuff, right? And then people on forums, real technology, something, real world technologies, foronics and stuff. I think in the meantime, I think I do not even discuss stuff on foronics and stuff. This just makes me depressive when people claim they are experts and argue there about read file system calls that are their words amazing, my word a little bit superfluous. And anyway, yeah, 2021 we might get a new read file system call for reading a small file in one system call, but still have vulnerabilities all over the place. How can we do better? Of course, writing stuff in more secure languages. The problem here, of course, that inherently C a very unsafe language with pointer dereferencing and buffer over underruns all over the place. Basically, it's up to the programmer to check their stuff, and recurrently here and on the More News channel, this stuff goes wrong. So we need better languages, more secure languages. Even if it just helps the programmer 90%, I would already say that's a 90% improvement. Many people, of course, nowadays Rust and more Rust. Personally, I find Rust not the most usable, and yeah, there's always something, right? There are 14 languages and experts still find them not as amazing, and then there's the 15th. Anyway, make it in Rust, I don't care. Take anything that is better than C. In my opinion, the usual flame war type of stuff, C++ would have even been better, so we would not have had to wait for Rust. We could also have already done lightweight C++ for some better buffer length checks and handling, and maybe even more automated logging and stuff. And no, it doesn't do random stuff under the hood and is verse to review and read and stuff. I would still argue that even that would have been more readable and certainly less error prone with some proper buffer handling of in-kernel buffers having an explicit size and being more automatically checked. And this would not kill performance. You need this buffer checks anyway if you have some nice primitives for that in C++, Rust, or whatever. Anyway, we, in my summary and opinion, need to do much better than that. And is that all? I also have one more thing. I mean, obviously, I made the previous video. If you're new to this channel, I do this recurrently, also news more on the More Life channel. I recently also went like 30 minutes or so through all just the 5.10 CVE security vulnerability reports, and this, of course, the next one. So if you are interested in this kind of stuff, maybe you want to share, like, and subscribe. Another thing that shocked me is here Stephen Rosted of all kernel fame wrote here on Twitter the other day, with caught my eye. Wood never knew RM mod was an unsupported best efforts feature, like AstraZeneca shipments to the EU. Best efforts, like, yeah, YOLO, whatever, don't do it much. No longer need to fix bugs caused by module unloading. Yay! This is, of course, the usual stuff that is growing really thick and tired of me. What they mean is, it's like sysfs add optional module owner attribute needed, otherwise the owner of the attribute on group read store might have a shared log used. On driver removal, it's like Greg KH of, what was it, Hartmann, no full name there, Crow Hartmann, I think. Please know, module removal is best efforts. Like, yeah, I mean, seriously, imagine, sure, it's not executable. But how crazy is it, right? People argue with me the Linux kernel is also modular because it has modules. It's like nearly a microkernel. No, of course it's not. We need more separated stuff. Ironically, recently, maybe I should have opened that. Recently there was a USB vulnerability in Fuchsia. USB vulnerability in Fuchsia. And that could only take over the USB subsystem, which is of course maybe this one. Security researchers attack Google's mysterious Fuchsia. What they found. Was it this one? Contrary to every other major, it appears rather difficult to target the Circon kernel. Circon is the underlying smallest microkernel component on which all the other services like USB file system and stuff are running. Basically a multi-server microkernel, like I'm already advocating for over a decade and the last years here on YouTube. A successful remote code execution on the world-facing part of the system, USB, Bluetooth, like Bluetooth, BadVibes and stuff. Network stack will only give you control over the targeted component, but they run an independent userland processes. Is that not amazing? I actually, maybe I should just fork Fuchsia right before Google brings it to market. Like, yeah, this is what big companies do. Maybe just fork it to BetterFS and call it a day and don't spend my next 10 years to write my own microkernel. Not everything I see in Fuchsia is amazing, but it's certainly pretty good. And this is also crazy, right? 2021 we sit here and long-term Linux kernel contributors like, yeah, please give me microkernel, please. Let's switch to Fuchsia or something. And this is how it should be, right? It should not be that a security vulnerability or 3 in Bluetooth give you full kernel, remote kernel code execution. But at worst, if there's a bug, I think was a C++ maybe, although they have a mix of languages, need to check what exactly the USB and Bluetooth stuff in Fuchsia is. Yeah, run independent userland processes, not in the kernel from a component. You need to escalate privileges to the kernel using the limited number of syscalls you can access with the handles you have. And initial attempt found a vulnerability run indeed dead ends, resulting in minor bugs, among one of out of band access issue related to your USB, fetch descriptor table, something, found 2 different minor bugs in the Bluetooth stack, one related to how handling rejected packets, not interesting bug from an exploitation point of view. Unfortunately, the other parsing service search response. Again, this could be at best allow limited denial of service attack on the Bluetooth component as an investigation, but it's not interesting. So yeah, and then maybe I need to make a dedicated video. But in general, I'm not impressed. People always take everything that Linus Torvalds says with the final wisdom. And I have to come to the conclusion that, of course, he is very biased. Of course, his system is very widely used and successful from a installation-based point of view, but neither from innovation. It's the same good old Unix C that you had in Solaris, AIX, and all the others. Basically, you could obviously usually call it a clone of some Unix. Innovation there, very little. There has been more innovative stuff, even Minix, as much as it will trigger Linus Torvalds. I'm personally not the most impressed by Minix, but at least they were innovative. And then, of course, plenty of other stuff. Maybe Amöbia, what this was, and Barrelfish, and L4 for not only microkernel, but at the time, or still the world's fastest content switching microkernel. And in general, this no microkernels thug is not an argument. Sure, the performance might be 9% or so lower, but there are plenty of things, including as proposed by myself until I realized this was already proposed earlier, vectored system calls, vectored messages, don't context switch for one thing, context switch for many. And of course, what the Linux kernel also nowadays does with IOU ring for user space IO ring, high performance stuff. But anyway, so just some more data pains. Data pains. for this data points of BadVibe and Bleeding BadKarma, and let's check the marketing names of BadChoice. Last but not least, so yeah, module unloading, just that you know, good luck. It's also crazy, right? This is also where you see that those Linux kernel people, it's so funny, right? To me or other people, they tell your multi-server stuff will not work because your graphic stuff will not be secure if you run your like old, actually yes, it is a little bit like old-fashioned Xorg, but I would still argue it improves security when you don't have graphic components in the kernel, because it makes it one address space more separated and one layer to attack more. And their argument is, of course, yes, bus master DMA, you can DMA stuff with your GPU from left to right, from yes, but still you trust your driver anyway, right? This would be the same as you have a similar bad driver in the kernel. So by saying, yeah, you can still DMA from address 0 to FFFFF, it's like, sure, you can do in the kernel as well. And then I rather take the address space separation running this in user space. At the end, you need to trust this anyway. And user space drivers, you can, of course, code sign as well. Not that I believe in code signing, but if you do believe in code signing, you can, for the added security of only vendors can run driver-like services. And last but not least, I would argue using, again, higher level languages, at least C++, but Rust, or whatever, Zig and whatnot, can improve reliability significantly with much more readable and more automatically managed code of more automated locking and all the fun stuff that you can do much more easily in higher level, more modern language concepts in user space than is allowed in the Linux kernel. But with the Linux kernel, so they on one side they say, no, you cannot have your GPU, your Bluetooth in user space because we don't trust it. And everything needs to be honky-dory, super amazing, super stable, which, yeah, fun fact, recurring seem right, as stable as the Linux kernel. Just try some recent dereference, fix null pointer, yeah, in even fbcon cursor, in case you were wondering. Anyway, and yeah, as stable as that. And so basically the Linux kernel people, their argument is always, we want full control. The system is only stable if it's all in the kernel and we have control over this. We have reviewed that and there is nothing from user space that can do poking on registers of GPUs or DMA, because that is out of the scope of the Linux kernel and it needs to be in full control of the Linux kernel. And yet they say, it's like, yeah, YOLO, whatever, unless you remove your module, because, yeah, it's super duper stable, except if it isn't, unless you remove a module because, this is best effort. Just don't remove a module. Who would do that, right? And also removing a module, right? You have a security fix in your driver or network stack, but it's like, yeah, it's crashing the server, crashing your data center because module unloading is randomly glitchy because, yeah, best effort. We need to have full control, but module unloading, that is difficult. That is similar to console scrolling, right? Console scrolling is too difficult. It's removed from it. Oh, by the way, it's annoyed already the hell out of me, the removed yeah, frame buffer scrolling, because I often on P3, SGOctane or other embedded stuff actually don't necessarily have Wayland or Xorg running, and it's actually pain in the ass. And this is hilarious, right? The Linux kernel people tell you we can do everything except frame buffer scrolling and module unloading. We actually have two things for that. One is that and the other is that. Yeah, last but not least, I have here one more thing. If you think, yeah, but I'm running Windows, that's certainly probably totally amazing. I have bad news for you. CVE 2021-3146 Dolby Audio X2 DAX2 API service before 08890 on Windows allows local users to gain privilege of like, yeah, 2021. Your all Dolby Audio whatever. Is this Atoms? I'm actually not sure if this is Dolby Atoms. It's some Dolby Audio stuff, local privilege. It's similar to NVIDIA driver previous. Oh yeah, right. yesterday we updated live on the More Life channel, we updated Sway that supposedly has fixed X-Whale and copy and paste, because previously copy and paste was only working reproducible every second time, and now with yesterday's Sway update, copy and paste does not work anymore at all. So amazing improvement, total fix. Anyway, C must be an amazing language. They all got this very well. Oh, Lenovo support, even their stuff. I'm more interested what that is actually. Maybe Wikipedia, because I certainly know Dolby Atoms and stuff, but I'm not entirely sure what X2 is. It's probably something, whatever. Anyway, that's it for this video. I hope you learned something, I think I focus on spreading my word here on YouTube and comment less on some random forums, because this is simply, and then people tell me I'm too elite of, when it's like everything I heard here is like random, no data point, random wishful thinking. Something I'm elite something, whatever, snowflake something, because anyway, that's it for this video. I hope you learned something, and I probably on the More main channel there in that corner, we recently have done a lot of Linux work, but our ISOs are now 99-ish complete. Speaking of 99-ish complete, let's continue with Intanium 64, because obviously someone needs to maintain that. I previously had here a weekly security vulnerability breaking news summary. Some of the last weeks I've been a little bit busy and it was a little bit repetitive for me, but maybe I should continue that, because the last 2 months where I didn't do that, there were obviously plenty of similar vulnerabilities. I'm certainly very much aware of that, but this is also why, what motivates me to use this medium here and build this channel, to motivate more people to do more modern and more secure stuff. Of course, modern does not necessarily need to be better, but I would usually hope that it still inspires people to do it still better, not only more modern. Like modern, you can also write security vulnerabilities and bugs in Rust. But anyway, think more about this, like automated locking constructs and memory size handling and so many different things. And also with my microkernel stuff, maybe I should give Fuchsia a second try. The first try didn't boot much. People told me in the meantime it boots more in QEMU virtualization, so probably should give that a try, because most of the stuff, 90% of the stuff probably relatively good. Of course, I always find some issues to nitpick, but it's certainly still a huge improvement. And that is also said, right? We did 30 years, also over 30 years of free software before GNU and Linux and all the other stuff, and yet we are big mega corporations need to write a whole new multi-server microkernel. Sure, there were other stuff, including open source L4, but not who system designs. And I'm also still thinking and brainstorming what the future of computing actually really should look like, because it's actually a relatively easy thing. Well, it's certainly a very easy thing to copy a Unix system, because you can just YOLO everything in one address space, and it was done and people know how to do it. It is a little bit more challenging to do a really good multi-server system, as seen in GNU Mach, of never ending and not being much worked on. Of course, there were better ones in the meantime. And it is even more challenging to innovate even more new stuff. Of course, there was other stuff like Plan 9 from Bell Labs, with a lot of innovative or everything is a file concept, yet everything written in C, or actually invented UTF-8 for all the things invented there. But there are, of course, multiple things. Should stuff be more AI? Of course, you cannot do AI of neural network, you will kernel, but you can AI more thing. Is something like Star Trek data the next big thing? Certainly not an easy thing, and maybe something like Neuralink or what their name was, trying also, not exactly, but at least a little bit. And certainly I'm not creating some positronic network thing here in my basement, but still these are valid concerns of, does it make sense to spend 10 years on a multi-server microkernel? Maybe it does, maybe you should just concentrate on Fuchsia as good enough and do more innovative stuff. The next thing also, there is persistency with potential eventually, not Intel Optane, but other memristor, I think it was Hewlett-Packard memristor stuff, like fully persistent systems. Of course, they are huge challenges, right? You think fully persistent stuff, you clobber some random memory and then it's persistent, you continue executing this and it becomes more corrupted and more corrupted. Maybe that's also the reason why a lot of this research didn't go anywhere. But yeah, or should everything, what previous video, if you're new to this channel, there are already hundreds of previous discussions, like should a modern system not even try to ship all the old-fashioned Unix components, but be more fully modular, as in smallest common subset without much, and running everything in small app sandbox containers, everything from file system, like app store or file system and stuff. Sure, not everything is easy. Not saying it's super easy to have their app store or remote repository, whatever you want to call it, and individual components, but think Kubernetes and containers and like everything sandbox first. And that is also the thing, right? The Linux kernel innovation is very skin deep. It's basically good old-fashioned Unix services copied. Sure, there is some stuff like dbus, udev, systemd, but the innovation of systemd, sure, there have been 20 init systems before. It's a little bit different, but not that much. We had Upstart, we had LaunchD for macOS, that is maybe even open source. And after all, it's sure they do something of HomeD, but it's not the big innovation, in my opinion. It's some services here, some fiddling there. At the end of the day, it's still good old-fashioned Unix with a single address space, monolithic kernel. But leave in the comments below what you think. Just a little bit of more inspiration of there is not only black and white, and there is not only good old-fashioned general purpose computing. We have some comments, so as usual, don't forget to share, like and subscribe. I hope you learned something and enjoy this channel. Brents asked to know your computer hardware. Well, I have hundreds of videos, right? If you mean my current workstation is AMD Ryzen. I even have the overkill build. Also, ASUS BIOS, amazing software, right? ASUS, previous video, ASUS BIOS update burned my 5950X memory channel A. Only channel, can't make this stuff up. Otherwise, I also have an Octane and PS3 and all this good old stuff for testing. But of course, I neither use the PS3 nor the SG Octane on a daily basis. My workstation right now is a 5950X, if you're into that kind of thing. Not too fancy with some compute cluster stack here in the office for our business services. But if that is what you meant, then otherwise leave it in the comments below. People appreciate this talk here. That is nice to hear. Unbiased writes, what do you think about what exactly are you interested in? CL8. Goku got a new laptop, uses Bluetooth mouse and SPC that's set up with Bluetooth mouse keyboard. That is really crappy news. Yeah, the good news is you can update simply your kernel. The bad news is that probably only so far that they find the next vulnerability. I would also say Bluetooth keyboard and mouse is still a step up from vendor proprietary. There's nothing worse than this Logitech or something vendor proprietary, also previously hacked and not And then often it stays not patched because vendors, YOLO, whatever, not patching our wireless keyboard and mouse stack there. And Ace Attack writes, immutable OS like Fedora, Silverblue, and SUSE Micros trying to do that. Mutable OS layer, you can containers for special packages and Flatpaks, desktop GUI app like Firefox. Yeah, so there is certainly a lot of stuff, and we urgently need to, as a community as a whole, do much better, right? I'm really seeing black. We see now daily, which is also why the last 2 months stopped this breaking IT news. We see daily vaccine stuff hacked, vaccine apps hacked, ransomware on car companies, suppliers, and everything, universities, courthouses and schools and hospitals and stuff. And this is really, this is just 30 years of bad engineering, and people still don't want to believe that, right? People still are trapped in their reality distortion field of Linux is the best and monolithic single address based kernel is the only and best way to go. And sure, microkernel could have 9% less performance, but when you take a look at Intel Spectre and Meltdown, 9% by the way, just a ballpark number, and we easily sacrificed 9% performance on Intel Spectre Meltdown mitigations or other AMD ARM. And so, yeah, that Linus Torvalds says he doesn't believe in the microkernel stuff. This is from a performance is everything view. And if you change your point of view just a tiny little bit and also want stability of module unloading is not best effort and other stuff is more secure and stuff is maybe more usable, maybe more flexible, and certainly more secure, I would rather take the 90% more secure and 10% less performance, and certainly the hospitals and industrial factories or infrastructure, electricity, water, and so on. I actually wonder that this is a question, right? I wonder that it's not the default of 90% better security and on the cost of 10% performance. Why is that not the default choice? Because the daily ransomware hacks and so on is just the result of performance, and security is like best effort. Actually, you could use the same term of security is best effort because we manual pointer dereference and length check, bounce check stuff, and it's the best effort, right? Maybe some human got it right, but often they don't. And I hope you learned something.